welcome to today's lesson. Today we'll be talking about families of elements in the periodic table in chemistry. The periodic table is made up of the vertical column, which is called the groups. Every group have the same number of electrons in their outermost shell. Now, we have different groups in the periodic table ranging from group 1 to group 8. The same number of electrons that they have in the outermost shell determine their chemical properties. Now we have the periods. The periods are found in the horizontal row of the periodic table. Elements in the same period have the same number of shells, and this shows their energy level. Now we have about seven periods in the periodic table. Now we are going to talk about each group and their characteristics one after another. The group 1. Elements in group 1 are said to be univalent. Univalent in the sense that they give up one electron that they have in the outermost shell. So they ionize by giving up one electron, donating it, and forming a covalent compound with a non-metal. And by losing this electron, they are able to attain the octet electronic configuration of the noble gases. And these characteristics always make them good reducing agents. These group 1 elements, they are called the alkali metals. Alkali metals in the sense that they react with cold water to liberate hydrogen gas, and as a result, they form alkalis. Here we can see potassium reacting with water to form potassium hydroxide and giving up hydrogen. We have different examples of elements found in group 1, which are hydrogen, we have lithium, we have sodium, potassium, rubidium, cesium. All these elements are found in group 1, and they show the same or similar chemical properties. Now group 2. Group 2 are called the alkaline earth metals, and they have 2 valence electrons in their outermost shell. In essence, we can say that they are divalent. So when they give up these 2 electrons that they have in the outermost shell, they are able to attain the electronic configuration of the noble gases. So this group 2, they are also metals, and they show the characteristics of metals. We have different elements that are found in the group 2. The first one among them is the beryllium. The beryllium followed by the magnesium, followed by calcium, followed by strontium. All these elements are found in group 2, and they show similar chemical properties. One of the properties that they have is that the calcium reacts with water to also form calcium hydroxide. But in this case, calcium reacts with hot water to form calcium hydroxide. We can also see that magnesium reacts with steam to form magnesium oxide, and in results, it gives us the hydrogen. Now let's talk about the group 3. The group 3 elements are said to be trivalent. What do I mean by trivalent? Trivalent in the sense that it has 3 electrons in its outermost shell, and it easily donates these 3 electrons to form an electrovalent compound. And as a result, they attain the noble gas structure. They ionize and look like the noble gases. Okay, we have different elements that are found in the group 3. Example, we have the boron, aluminium, we have gallium, indium, and thallium. All these elements lined up are found in group 3. Aluminum here, aluminum hydroxide, is said to be amphoteric. Amphoteric in the sense that it serves as amphoteric in the sense that it has the characteristics of acid and also has the characteristics of a base. So aluminum hydroxide can react with an acid. It can also react with a base. For example, aluminum hydroxide reacting with tetraoxosulfate 6 acid to form aluminum tetraoxosulfate 6 acid. Now, the same aluminum hydroxide can also react with sodium hydroxide to form aluminum sodium hydroxide. So, in the first instance, we saw that aluminum behaves like have an acidic property. In the second instance, we say that aluminum has a basic property. Now, let's talk about the group 4. Group 4 elements, they have 4 electrons in their outermost shell. And these group 4 elements, they are called the metalloids. The metalloids in the sense that their outermost shell are not completely filled. It's said to be half-filled. So sometimes they show the characteristics of a metal, and some other times they can show the characteristics of a non-metal. Now, the group 4 elements, usually they exhibit 2 oxidation states. Oxidation states, sometimes they exhibit a +2 oxidation states, and some other times they exhibit a +4 oxidation states. Now, the first ones that are found in the group, such as the carbon and the silicon, many a time exhibit the oxidation state of +4. Whereas the other ones that are found later in the group, such as we have the tin and the lead, their stable oxidation state is usually +2 in most of their compounds. This group can have the metallic properties, can have properties of a metal and also properties of a non-metal. So we know the properties of metals, which are they conduct electricity, they are malleable, they are ductile, they exhibit all these properties, and some other time too they act as a non-metal. We have the group 5 elements. Group 5 elements, they show 5 electrons in their outermost shell, but they are able to accept 3 electrons to attain the noble gas configuration. These group 5 elements are non-metals. All the group 5 elements are non-metals, and because they are non-metals, they are able to show oxidizing property. Examples of elements that we have in the group 5 elements, we have the nitrogen, that's element number 7. We have the phosphorus, element number 15, arsenic, element number 33, antimony, element number 51. All of them are found in the group 5, and they show similar chemical properties. Okay, group 6 elements, they accept 4 electrons to attain the noble gas configurations. They have 6 electrons already in their outermost shell. These elements are said to be non-metals. They are electron acceptors. Yes, when I mean that electron acceptors, non-metals accept electrons, while metals donate electrons. So in this case, they are electron acceptors, and because they are electron acceptors, they have oxidizing property. They are called oxidizing agents. Now look at the reaction, the magnesium reacting with oxygen to form magnesium oxide. Here, oxygen is the oxidizing agent. It oxidizes magnesium, and oxygen itself is being reduced. So we have oxygen and sulfur can combine. Oxygen combines with hydrogen to form water. Then sulfur also combines with the same hydrogen to form a hydrogen sulfide. These are the characteristics of elements found in group 6. Then we have the group 7 elements. These elements have 7 electrons in their outermost shell, and they are said to be halogens. Halogens meaning that they are salt formers. They are the most reactive non-metals because they require 1 electron to be filled. So they are very, very reactive, just like the group 1 elements that are metals. They are the most reactive metals. We say here that the group 7 elements are the most reactive non-metals. So they are called the halogens, and they form salts. They are known to form salts. So we have different examples of elements found in the group 7 of the periodic table. For instance, we have fluorine, followed by chlorine, followed by bromine, followed by iodine. Now, fluorine and chlorine are gases. They are gases at room temperature. Then bromine is a liquid. Then we have iodine, which is said to be a solid. Fluorine has a characteristic color of yellow, just a yellow gas. Chlorine is a greenish yellow gas. Bromine is a liquid, which is it has a reddish brown color. Then iodine is said to be a solid, which has a dark purple color. Now, one of the characteristics of this group 7 elements is that the reactive ones displace the others. The first element, which is fluorine, is capable of displacing chlorine in a chemical reaction. Chlorine is capable of displacing bromine in a chemical reaction. Bromine is capable of displacing iodine in a chemical reaction. Just let's look at this equation here. We have fluorine reacting with sodium chloride. Now we discover that fluorine displaced chlorine in sodium chloride, forming sodium fluoride and giving up chlorine. After the group 7 elements, we have the group 8 elements. These group 8 elements are also called the noble gases. We say that they are inert in nature. Inert in nature meaning that they are not easily reactive. They don't easily react. This group have 8 electrons in their atomose shell. They are complete. The atomose shells are complete. It has 8 electrons, so it doesn't easily react to form any bond. If it does, it's to be at a very high temperature. So these elements do not react easily. So they have attained the normal configuration that is supposed to. That's why they are stable. All the elements in the group 8 are said to be stable. Now they do not accept electrons, neither do they donate electrons. So they are classified as non-metals. So examples of group 8 elements, we have the helium, we have neon, we have argon, and krypton, and so on. So they are always found in free states. What do I mean in free states? Because they are very stable. They don't easily combine. So you can actually find them in free states in the atmosphere. So after the group 8 elements, we have the transition elements in the periodic table. Transition elements are elements that are found in between the group 2 and the group 3. They are metals that have the typical properties of metals that we know. So these metals, they have a specific characteristics such as they have variable oxidation states. We also know that they have colored ions. Also, they serve as catalysts. Example, we have the vanadium 5 oxide serving as a catalyst in the preparation of ammonia. Also, these transition elements also have the ability to form complexes. They form complex ions. So the last one here, we have the lanthanides and the actinides. These are the last group in the periodic table. They are found at the base of the periodic table. The lanthanides are also called the rare earth gases. They are found in the 6th period. Now, you discover that in the periodic table, there is a space between radium and before you get to the transition elements. That's where you find the lanthanides. Now, the lanthanide starts with the element lanthanum. That's where we got the name lanthanides. Now, the actinides are below the lanthanides. They are placed in the 7th period, and they are known to be artificial elements. Artificial elements in the sense that they were synthesized in the laboratory. They do not occur naturally, just like they were discovered during nuclear fission or nuclear reaction. These elements are very, 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 very unstable. They are very, very unstable. They disintegrate within a very short period of time. So these are the groups and the periods that we find in the periodic table.